Hi class 12. So in the last video we saw the introduction of alternating current, why is it called alternating current, and we also checked the mean value of the alternating current. The mean value of alternating current was 0.637 of the peak value I0. In the video I kept on saying 0.631, but it's 0.637 of I0, mind you, the mean value. By the way, mean value for half a cycle, mind you, it's not for a full cycle, because the mean value for a full cycle was 0. And we also checked that if we have capital N number of variables, x1, x2, x3 up to xn, then the mean square value of x was the average of the respective squares. Alright, so x1 squared plus x2 squared plus xn squared divided by capital N, this was called the mean square value. And what was root mean square value of x therefore, or x RMS is equal to square root of the mean square value. So this is what we checked already in the last video. Okay, so in this video today what we are going to look at is, first we are going to look at the RMS value of the alternating current. Now since I don't want to waste much time doing the mathematics here on the board, okay, so I don't want to make the video long, so therefore I have first worked out the mathematics here to calculate IRMS, okay, and I just want to show you the steps. You can copy the steps if you wish to, or the steps, it's there in the book as well. So IRMS, the root mean square, is the square root of the mean square value of the current. The bar over here, like I've already told, means mean value, represents average, okay, so mean square value of the current source. See, so let us first calculate the mean square value. Once we get the mean square value, we can easily calculate the IRMS by finding the square root of it. So mean square is 1 upon capital T, that is we are calculating the mean square over a complete time period. So integration of I squared dt. Alright, mean square value of different x's was x1 squared plus x2 squared plus xn squared divided by the number of variables. Alright, so the integration of I squared represents the numerator over here. Integration means summing up, don't forget. And divided by the number of variables means you are integrating over a complete cycle, so divided by the time period, remember. Okay, likewise we calculated the mean also. So mean squared value therefore is 1 upon 2 pi by omega. Instead of capital T we write 2 pi by omega. Integration of 0 to capital T is 2 pi by omega again, and the instantaneous value of current I is I0 sine omega t. So therefore the square of that is I0 squared sine square omega t dt. So I take out I0 squared outside the integration, since it's a constant, the peak value is a constant, so we get this integration of multiplying and dividing by 2. So inside the integration we only have sine square omega t dt, so multiplying and dividing by 2 we get this. So this 2 is also taken out of the integration since it's a constant now. So we have this outside the integration. So the limits of integration are still the same. Now 2 sine square omega t is 1 minus cos 2 omega t, because 2 sine square theta is 1 minus cos 2 theta, mind you. So we have this inside the integration. So mean square value, therefore the thing outside the integration is still the same. And inside the bracket what we do is we separate these two integrations. Alright, so integrate, this becomes 1 into dt is dt, so integration of dt from 0 to 2 pi by omega minus integration from 0 to 2 pi by omega, that of cos 2 omega t dt. So this gives us integration of dt is t, and the limits of integration is 2 pi by 0 to 2 pi by omega, and the integration of cos 2 omega t is sine 2 omega t divided by 2 omega. Okay, because the integration of let me write it over here, integration of cos 2x dx, say for example, is sine 2x divided by 2. Alright, so we have sine 2 omega t divided by 2 omega over here, the integration of cos 2 omega t. Now we have to substitute the values of the limits of integration. So mean squared value is this thing outside the integration is still the same. So we first of all substitute the upper value. So 2 pi by omega minus 0. Alright, and we see that the second term, when we substitute both of these values, what we get is 0. Because let me show you verbally, okay, by substituting this upward value first of all. So the value of t is 2 pi by omega because t is the variable. So when we substitute t, when we substitute 2 pi by omega instead of t over here, this omega and this omega, they divide each other out. So therefore what we have in the numerator is sine 2 into 2 is 4. So sine 4 pi. Now sine 4 pi is 0. And then we substitute this lower value. So t is 0 now. So this becomes sine 0. Sine 0 is 0. So 0 minus 0 is 0. So we have this. Okay. So mean square value thereby becomes omega by 2 pi into I naught square divided by 2 into 2 pi by omega from here. Alright, so omega, they divide each other out. 2 pi, they divide each other out. So therefore, what do we get? We get the mean squared value to be equal to, let me erase this part over here. Okay, so what we get is the mean squared value, let me write, mean squared value is equal to I naught squared divided by 2. That is the mean squared value we get. Okay? You can pause the video and copy this. Alright? Therefore, let me erase it now. Let me erase this also and write over here. So, mean squared value is I naught squared by 2. Therefore, what is the root mean squared value? Therefore, root mean squared value RMS, which is the square root of the mean squared value, mind you, is I naught divided by root 2. So to say, or IRMS is equal to 0.707, I hope this value is correct now, 0.707 of I naught, because 1 upon root 2 is 0.707. Okay, or so to say we can write, or IRMS is equal to 70.7% of the peak value of the alternating current. So, if we have an alternating current over here, this is current I along the y-axis and time or omega t along the x-axis. So, if this is the peak value, then the root mean squared value is somewhere over here. 70.7%, somewhere here. So this is your IRMS. This is your IRMS value. Now get one thing very clearly over here, class 12, that you may not be asked to do the whole derivation. Okay, you only have to know, of course, how to do the mathematics, how to solve the mathematics. What is important for you all is you need to know that IRMS is equal to I naught divided by root 2, or so to say IRMS is 0.707 into I naught. Okay, this is very, very important. The IRMS value is 1 upon root 2 times the peak value of the alternating current. This is important for you all to understand, remember that. So we've seen that IRMS is I naught by root 2. So this brings us to one famous question, which is, if we have a DC source of 220 volts and we also have an AC source of 220 volts. 220 volts AC source is what we use in our houses. Okay, so at home the power supply, the alternating current voltage that is supplied to us is 220 volts. Okay, so we have 220 volts AC and 220 volts DC. The question is, which one will give you more shock, more electric shock? Okay. Now, the answer to this question is AC will give you more electric shock. 220 volt AC will give you more electric shock. Why? Because 220 volts of AC that we get at home is the RMS value of the voltage, remember. Okay, so to say this is VRMS, whereas for DC, this is the maximum voltage of the DC. So if we plot DC voltage, so this is DC with time, okay, this is 220 volts max. Whereas for AC, VAC with time, of course. Okay, it is varying this way. So it is, alright. I hope you can see the invisible part over here. Alright, so 220 volts is somewhere around here. This is 220 volts, it's not the peak value. So to say, if you want to get the peak value, so to say, VRMS, this is 220 volts. This we know is equal to V0 by root 2. Same as in the case of current. Alright, so therefore, V0 will be root 2 into 220 volts. This comes out to be equal to somewhere around 311 volts. Okay, so at any instant, you might get a shock of 311 volts if it is a 220 volts AC supply. Remember that. The last topic for this video, which is phasors and phasor diagram. Now, what are phasors? Phasors are rotating vectors, so to say. They are vectors essentially. Okay, so a diagram showing alternating current and alternating alternating voltage as vectors, which are rotating vectors, and this rotating vector is what is called a phasor, mind you. With a phase angle between them is called a phasor. So you have a diagram, let's call it a graph, okay? So up to here, this vector is I0, that is, this is representing your current, and this vector up to here is V0. This vector, so to say, is representing the voltage. Alright? So they have the same phase in this example, which is omega t. Omega t is the phase that they have, or the phase angle that they have. So I is, so to say, I0 sin omega t, V is V0 sin omega t, they have the same phase. Okay? So this is an example of a phasor diagram. You can also have different cases, like the phase angle between the current and the voltage could be different. Okay? It could be like the voltage is leading the current by pi by 2. Say for example, this is pi divided by 2. So here they have different phase. I has phase omega t, whereas V has phase omega t plus pi by 2. So to say, if we are to draw a phasor diagram in this case, so it could be, since the voltage is leading the current by a phase angle of pi by 2, that is a right angle, so to say, the picture could be like this. Okay, so this is your V0, and thereby this is your voltage, and this angle is, of course, pi by 2. Okay, the phase angle of the current is omega t, and the voltage is leading the current by a phase angle of pi by 2. So this is pi by 2. Okay, so this also is a phasor diagram. There could be cases where current leads the voltage. Alright, okay, so this is another example of a phasor diagram. We can also have a case where the current leads the voltage by a certain phase angle, need not necessarily be pi by 2. Okay, now whether the current leads the voltage or the voltage leads the current, or like in the previous example, they have the same phase. It all depends on the circuit through which the alternating current is flowing. Okay, so in the next video we are going to discuss about different kinds of alternating current circuits.